having just done this question, okay, you ought to be able to anticipate a lot about this question because you basically got the same thing but upside down. Okay, but still, let's go through it slowly. All right, now get your ruler out. This is what we know about the first derivative. Okay, so at these 2 points here, the roots, right? Okay, those are going to be stationary points in the graph above. Yes? Okay, so let's put our ruler on the board, paper. Okay, so far so good, right? Now, before I go up, I'm going to go down because actually it will, number one, it's easier, as you saw. Number two, actually what we see down here will help us to graph what's above, okay? So for instance, on this graph, I have the derivative has a stationary point. Does that make sense? Not this graph has a stationary point. There, make sense? So what that should correspond to is a root down here, right? Okay? Now, pay attention to the gradient here, right? It's increasing and then it's decreasing. Increasing, 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 and then decreasing. Okay? So this is a parabola. We're expecting some kind of straight line down here. But since it should be positive going to negative, it's going to be going downwards, right? Okay, now this is important for us because as we go up to this graph, right, I'm expecting 2 stationary points, okay? But, see, this is a bit like determining the nature of a stationary point. Here, this information down here is telling us the left-hand stationary point should be concave up, right? Concave up, because the second derivative is positive. So this stationary point up here is going to be facing up. Okay, so it's a minimum. Okay, this is a minimum. In the same way, or rather in the opposite way, this one will be a max. Okay, so that tells me if this is going to be a minimum and this is going to be a maximum, that tells me something about their relative location. Okay, you can't have a minimum above a max because then it wouldn't be a minimum, right? It would be a max, right? So therefore, the minimum, I don't know where it's going to be vertically. It could be anywhere. Let me just put it there. Okay, I've drawn a horizontal line because it's a stationary point. The max must be above it, right? So something like that. Now again, because I don't know any scales, this could be all up above, or it could be closer together or further apart. I don't know, but I'm still getting the general shape. Okay. So to join these two, again, I'm going to be expecting right in the middle there should be a point of inflection. Yes. So something like this. Okay. There's my point of inflection. Okay. And the rest of the graph, well, let's have a look. On the right-hand side here, the derivative is negative, so I'm dropping, as you would expect any good cubic to do. And over here, right, again, the first derivative is negative. Okay. So that's why this is also dropping. Okay. Ta-da! Now, in terms of the roots, like these things here, they could be anywhere. The things we're paying attention to are the critical points. Where are the stationary points? Which way do they turn? Where's the point of inflection? Okay?